So we're going to review completing the square. It's actually, there's nothing to really understand here, nothing new at all, just a way of changing the form of a quadratic. So let's start by seeing what do we mean when we say perfect square. We mean something of this form: x plus a, the quantity squared, or x squared plus 2ax plus a squared. If you FOIL that out, you'll see that's what it is. Now, before I start showing you how to put something into that form, I'd like to go over how do you multiply it out quickly. I've noticed that several students are still foiling, and actually these are very quick to multiply out, and you should be able to do it quickly. It'll save you time to concentrate on more important things. Notice you square the first term and you multiply the two together and double it. So double the product of the two terms plus the second one squared. So let's do an example real fast, like how about 2x minus 5, the quantity squared? Well, I'm going to square the 2x, so I get 4x squared, and now I have minus 10x, doubled is minus 20x, plus 25. Or even something like xy squared minus 2z cubed. Okay? Look how fast you can do it. Square the first. That would give us x squared, y to the fourth. The product of the two is minus 2xy squared z cubed, and we're going to have minus 4 of them. We just double it. So we have xy squared z cubed plus the second one squared, 4z to the 6th. So just think that sentence in your mind. First one squared plus twice the product of the two plus the second one squared. Sometimes you don't want to expand things, you want to put things into a different form. For example, let's write down again, x plus a, the quantity squared, is equal to x squared plus 2ax plus a squared. Okay, so notice the coefficient here is twice the product. This term here is twice the product of the two. The coefficient of x is is double a. So if you divide the coefficient of x in half and square it, that's what you have here. The coefficient of x in half gives you a, and you square it. So if we want to complete the square on x squared plus 6x plus 3, let's say, the first thing you do is just move over the 3. Whoops, excuse me, it's x. Just move over the 3. And now you take half of the 6. Half of 6 is 3, and you square it and add it. Plus 9, and of course, minus 9. We really don't want to change the quantity. So what we have now is x plus half of the 6, x plus 3, the quantity squared, minus 6. That's completing the square. Let's say we have x squared minus x plus 9. Again, put your x squared term first, your x term, and just have the plus 9 over here waiting. Okay, half of the coefficient, well, the coefficient of x is minus 1, so half of it is minus a half, and you square it and add it. Plus 1/4, and make up for it with minus 1/4, and we have x minus a half squared. And then what's that? 18/4 minus 1/4 is let's see, excuse me. 36/4 minus 1 is plus 35/4. So let's take one that doesn't have the coefficient of x. 2x squared minus 3x plus 1, let's say. We want to complete the square. Well, our pattern, let's write it down again, is x plus a, the quantity squared, is equal to x squared plus 2ax plus a squared. So we see that the coefficient on this pattern, the coefficient of x is 1. So let's just factor the 2 out. Factor the 2 out, and we have x squared dividing the coefficient of x by 2. We have minus 3/2 x. And again, close the parentheses. We leave a space. And we still have the plus 1 hanging on over there, but we divided the 2 from the coefficient of from x, the term with x squared and the term with x. Now I have a 1 here on x squared, so I can do exactly the same thing. Take half of that minus, just double the denominator, minus 3/4 squared, and add it. So that will be plus, it's always plus, 9/16. But now notice that what I really added was 2 times 9/16. So I don't want to subtract 9/16. I want to subtract 18 over 16, which we could simplify, but I'll write it like that. And that gives us 2 times, and this is our a, x minus 3/4, the quantity squared, plus, well, let's see, that is, what do we get here? 18/16 is 9 over 8. So 8 over 8 minus 9 over 8. Oops, this is minus an eighth. So this was the one that we had in class, in our in-class work. We had minus x squared plus 2x, and you were supposed to complete the square. Well, here the constant term is 0. So we have our x squared and our x, but our coefficient of x squared is not 1. So I want to factor out that coefficient, factor out the minus 1, and I have x squared minus 2x, and I'll leave a space. Notice if you multiply this back, you get minus x squared plus 2x. Now the coefficient of x squared is 1, and I take half of the coefficient of x minus 1, squaring it, and I add it. So it's plus 1. Now look what I really did here. To the right-hand side here, I added a negative 1, because if I multiplied this out, it would be minus x squared plus 2x minus 1, so I want to add 1 to make up for it. That completes our square, and we have minus x minus 1, the quantity squared, plus 1. So you don't need to watch what I do next, but I just thought you should see it. I'm sure you saw this in high school, but you weren't paying attention, and now you'll understand it. If we have an equation, ax squared plus bx plus c equals 0, and we want to solve that equation, what we do is complete the square. So I factor the a out from the terms with x, so I have x squared plus b divided by a, x, and I leave a little space and have the plus c hanging on there, equals 0. Now I take half of the coefficient of x, which is just doubling the denominator, b over 2a, and I square it, and I add it. So I add plus b squared over 4a squared. Now, what did I really add? Well, in red, let's multiply it out to make sure. I have to multiply this times that to see what I really added. How much did I change it? Well, multiplying that together, one of the a's cancels, so I have b squared over 4a. So I need to add that, I need to subtract that. So I could subtract that right here, minus b squared over 4a. So now that completed the square, and since we're we're solving an equation, I guess I'll move these to the right-hand side. So I have a times x plus this, half the coefficient of x, b over 2a squared, equals, and let's move this stuff over. So if I add b squared minus 4ac to both sides, over 4a, and minus c. Okay, so we want to finish solving. So I divide both sides by a to get my perfect square on the left. So I have x plus b over 2a, the quantity squared, is equal to, and I have to divide by a, the whole right-hand side. So I have b squared over 4a squared minus c over a. So let's add those together. I need to multiply this fraction to get a common denominator by 4a on the top and 4a on the bottom, giving me b squared minus 4ac here, and on the bottom I have 4a squared. So I have this perfect square is equal to this. So I want to take plus or minus the square root then. I don't need that. X plus b over 2a is equal to plus or minus the square root of that number, b squared minus 4ac all over 4a squared. So you can see the quadratic formula popping right out here. So I will add minus b over 2a to both sides, getting x is equal to minus b over 2a plus or minus the square root of b squared minus 4ac, and since the denominator is a perfect square, I'll take the square root off. Oh, I have the same denominator. So x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. And that was by just completing the square. That's how you prove the quadratic formula. So anyway, I hope that you will be able to use this when we get to partial fractions. You'll need to be able to